thanks everyone for coming to the seminar today. I do appreciate that it's the day before Easter, and I'm very pleased to see a very good turnout from my lab. Shows who's committed to the cause, but also obviously a lot of people interested in crown-of-thorns. So it gives me great pleasure to welcome Dr. Dave Williamson here today, who's currently actually the director, acting director of the program at the Broomba, which he's going to talk about today. But he has had a long and enduring affiliation with James Cook University. He actually did his PhD here around the time that I did, and was also actually a fellow within the centre for a period. He's probably best known for his work in establishing the inshore monitoring program for fish on the Great Barrier Reef, which really clearly demonstrated the benefits of marine reserves for coral trout. And there's a whole series of papers that arose from that really important work. So Dave, for his sins, has now come over to work on the crown-of-thorns culling program, and he's going to talk to you today about the amazing developments and progress that that program has made in recent times. So,
thank you. Nice to welcome.
I had originally planned to do it, but it slipped my mind. But I do want to do a welcome to country and acknowledge that we are currently working on the lands of the Bindle and Woolaroo Bark people, and pay our respects to elders past, present, and emerging. Thanks.
Thank you, Morgan. That's great. Yeah, look, thank you, everyone. Thank you, Morgan. Great introduction. Thank you. And great work to country. Nicely done. Yeah, so look, yeah, my history is in marine research, and and consulting private sector and government funded research. And then I transitioned into working for the Marine Park Authority about 18 months ago, and was lucky enough to go straight into working on this program as the assistant director. And it's been a really fantastic journey so far. I was, pleasantly surprised when I arrived at Broomba that there was, the program was actually functioning despite a few problems here and there and bits to tighten up. It was generally working, when I arrived, and there's been a big evolution over these last years. And we'll talk a bit more about sort of the process that's been followed over these recent years, and some of it's been fairly ad hoc and sort of organic. But now we're in a position where we're actually able to have secure money right through to 2030, and we're able to be much more proactive about what we're doing in the program. And some of the work that Morgan and his colleagues have been involved with, it's established our entire knowledge base of what COTS do on the Great Barrier Reef. And between that work, the AIM long-term monitoring program, it's given us a really good understanding of the dynamics of COTS and coral across the reef and how these things are interacting. So again, I'd like to acknowledge the Bindle Woolaroo people on the land and sea country that we have here in Townsville. But this program operates right throughout the Marine Park. And I'd just like to acknowledge the enduring connection with traditional owners right throughout the GBR catchment to their land and sea country, and pay our respects to their elders past, present, and emerging. And in the TO space, that's something that we're really looking to develop a lot more over the next couple of years within the COTS program, and actually across the board more generally, is that we see that the knowledge that many of these peoples have, stretching back millennia, can really inform what we're doing on the reef, and also can empower us to do more. And one of the things that we find with the COTS program is that we're right at the limit of capacity. We have X amount of money to put a number of boats on the water and actually do the work, but we can always do more. There's always more we can do. This is a big problem. We're managing these COTS as a chronic problem now, rather than sort of responding in a sort of boom and bust kind of way. So TOs have got a really clear role to play in that. And you're all aware that we've got the fourth major bleaching event going on out there right now, and that's the fourth major bleaching event in the last 6 years. So clearly, in this position statement from 2019, climate change is obviously the greatest threat, and we need to be quadrupling, tenfolding our efforts to actually reduce emissions globally. But what can we do at scale that's actually going to create some sort of ecological benefit, resilience benefit for the park? What can we do now that's going to help us, survive at a time, protect as much coral as we can right now? And when we're looking across all the things that Broomba does, to manage the reef. And with our partners, zoning is really the biggest thing we do. And it's a cornerstone of marine park management. But what can we do on top of zoning to help it a little bit? Obviously, fisheries management is a big one. And we're working with the state government to do the fisheries management plans that are in place. There's still a long way to run in there. We also have a whole permitting system. But in terms of interventions and actual coral protection stuff that we're doing on the reef, the COTS program really is the biggest scale thing that we do. There's restoration programs and whatever your opinions are on that. They're all limited scale. They're all sort of test scale, proof of concept type stuff. A hectare or two maybe. We're talking about the COTS program we're rolling out over tens to over 100,000 hectares of habitat. So it's a very big scale program. It doesn't come cheap, but it's actually starting to really kick some benefit, some coral protection benefit goals. So our understanding of GBR COTS outbreaks, they tend to arise between Cairns and Lizard Island in an area that we refer to as the initiation box, or the initiation area. They also arise down here in the southeast corner of the Swains, and some of Morgan's recent work suggesting that there might be some linkages to initiation between Cairns and Lizard Island further north, between the far northern GBR and into the Torres Strait. So we are increasingly thinking about how we're going to be able to effectively manage COTS in the far northern region of the park. And it's not an easy thing to do because it's very remote, it's expensive to work there. But essentially, where we've detected COTS outbreaks, and there's been 3 major ones that the AIMS LTMP has picked up since the 1980s. We know there's a previous one to that in the 1960s. But essentially, they start here and they progressively track their way southward and get through to about some days where they sort of peter out a bit through this middle area, but that may be just an artifact that we don't look at many reefs in that part of the park. There's not very robust sampling of reefs through this area here. But there seems to be something also going in out of phase with the Swains, and they tend to arise right on this outside corner of the Swains here. And there seems to be some link there with major upwelling events when we see a lot of chlorophyll in the surface water. And maybe when coral conditions are right in the Swains, and there's multiple factors that potentially start these outbreaks off, just get the initiation of the outbreaks happening. But it's not as simple as clearing the land, more runoff, more nutrient. COTS outbreaks arise. There's a whole swag of potential drivers and potential contributing factors which drive the initiation of outbreaks. But you can see, if we look at this same animation from the LTMP program for coral cover, you can see there's essentially an inverse relationship between COTS outbreaks and coral. And Glenn Diath led a paper in 2012. It's getting a bit old now. But at that time, between the 80s and 2012, COTS counted for 42% of the total coral loss on the GBR. So it's well over a third. So if we'd been able to actually suppress COTS effectively and protect coral from COTS predation, we would have seen a slight increase in coral cover across that same period of time. So that's, by about 2012, that's when Ron sort of sat up and thought, right, well, this is something we can actually deploy at scale. If we had enough money to do this, and we had enough cooperation amongst all the tourism industry and the various parties that would need to be involved, we could potentially do something worthwhile. And that's really where the project sort of started off in about 2012 or so. And Dave Westcott, who's at CSIRO and was quite involved in the COTS program development of our current sort of field method, the integrated pest management approach that we follow, and that was funded through a NEST program. He made that pretty cool statement, and I think that's true. Is that we don't have robots out there culling COTS right now. This is all humans, and humans are amazingly good at getting in the water, finding things, and killing them. We're pretty good at fishing stuff out. We're pretty good at depleting things. If we just put that effort into culling COTS, we can actually do a pretty good job. So as long as we've got the methods right, we've got the techniques, and there's been various things that have happened through time that have allowed us to be much more efficient in what we're doing. And one of the major things I would argue is this one-shot technique. And Morgan's lab were actually pivotal in that when they discovered that you can use biosalts rather than some of the previous chemicals that have been used. And when this sort of started off in the 1960s, they were actually using quicklime. And I was spreading big lines of quicklime across reefs to try and pen the COTS into certain areas. Of course, everything that the quicklime touched would be dead, including all the corals and the invertebrates and whatever else was there. But yeah, they managed to get the COTS into certain areas for a period of time as well. So we've got resuspended and moved on, and then the COTS just called out and kept eating the coral. It's completely ineffective. But so there was a lot of developments prior to 2010. Obviously there was broad scale monitoring with the LTMP, there was fine scale monitoring with the CRC Reef project that was underway through the late 90s and early 2000s. So there's a lot of knowledge that was built up. So by the time the current outbreak kind of initiated in about 2010, 2011, or went to take it up in the reefs around this island, there was a pretty strong wealth of information that we could actually do something about it. So the one-shot technique, bile salts, and then just 3 or 4 years later, the discovery that we could also use vinegar made a big difference, because the previous injection media they used required multiple injections in each starfish. So every time you have to poke the needle into a starfish and inject it with a hit of something, it's taking time, right? So all your divers in the water, they're losing bottom time by injecting COTS multiple times. So the one-shot technique really improved the efficiency of what they were doing in the water. And it's given us close to 100% mortality on the COTS that are injected. So we're using still both bile salts and vinegar, and the different contractors that we have on the water using the different chemicals depending on what they want to do. But they're both equally as effective. The other big thing was the coral connectivity model and the COTS connectivity model. That really allowed us to start thinking about networks of reefs and connectivity networks, and really trying to work out how important individual reefs were as a source of coral larvae, and also how important those reefs were in terms of exacerbating or further spreading COTS outbreaks. So, all of that knowledge built up, and of course the models aren't perfect. And any of you who work with hydrodynamic biophysical models, you'll understand the limitations of these things. And if you have 3 different models, they'll probably tell you 3 different results. But so we're doing more in this space, and there's some of that work's being led through the Centre and Chiltern, Mike Bowe, but there's others, Siren and Ames, who are also leading this sort of work here. So this is improving. What we hope to have within the next few years is ensemble models that draw on multiple models, and where they agree, our confidence will be higher that those reefs are truly the important ones. So this is really important for informing where we're going to deploy the effort in the COTS program. We want to sort of weigh up all these metrics and select the best reefs, because if we can choose the best reefs, we have a much better chance of actually having effective coral protection within the program. Now we've just, I guess you've heard about this $1 billion announcement that was came out prior to the election. So the Marine Park Authority has got 250 million of that $1 billion, and 160 million of that 250 is coming to the COTS program. So that's really secured the program through to 2030. And as I said at the start, that's the first time where we've actually had such a long timeline. 8 years doesn't sound that long, but it is a pretty significant amount of time to get something worked out, right? So we've never been in that position before. It's always been 2 years funding, 4 years funding, a little bit ad hoc. It was largely run by the tourism industry from 2012 right through to about 2015. It was very focused on controlling COTS and protecting coral at key tourism sites. When we actually managed to implement the integrated pest management approach through the work of Dave Westcott and Cameron Fletcher and others, we were able to come up with a much more methodical way in which we go about surveying reefs, detecting COTS and steering the cull effort. And that's essentially over the last 4 to 5, 6 years now has enabled us to go from a site level protection to protecting coral across entire reefs. And we're starting to see now is that some of those coral protection efforts are extending to clusters of reefs and potentially across regions. We're also getting some indication from the Ames LTMP program that they're seeing at this time in previous outbreaks, they would have already been seeing outbreaks on certain reefs that are not occurring now. So there is some early indication already that we may have short-circuited at least part of the spawning potential within the COTS themselves, and potentially reducing the amount of recruitment we're seeing with some of the reefs that were previously impacted heavily in previous outbreaks. So there's a lot of things that have happened, and all this sort of fits within this sort of Reef 2050 plan. Is what can we do now to kind of future-proof the reef a little bit? And essentially, as I said at the start, we've got to get on top of the emissions. There's rules made very clear to the federal government about our position and what we need to do. But we need action, and that action has to be global. In the meantime, we've got to do everything we can right now. We've got to make sure the zoning plan is complied with. We have to make sure the permits are in place with fisheries and everything else. We can be close on all that stuff. We have to try and get COTS off the reefs where we can. And there's a whole swag of other stuff that we're doing as well. So the key objective of the program is really to protect coral on priority reefs. And as I said, the most important thing that we do is select the enriched reefs to protect the enriched reefs not to. You know, there's over 3,500 reefs out there. Just within the marine park, let alone extending across the Torres Strait to the CoralCoE reefs, southern Papua New Guinea. You know, we've thought, you know, the Barrier Reef we treat as a kind of isolated system, but it is connected to the CoralCoE, it is connected to the Torres Strait, it is connected to what's going on in the Louisiana reefs and southern Papua New Guinea. So, you know, we need to be thinking bigger about our management, and we are currently considering options to control COTS across the northern boundary of the marine park in partnership with the TSRA. So we're talking about ways that might be done. We haven't got a clear plan yet, but that sort of thing is starting. But right up through here, you know, this is the difficult part. Essentially, most of the operations that we're doing in the COTS program now are between Lizard Island and Lady Elliot in the south. Essentially, that's the area. That far north is we're really, really underground in the far north, and we're also reasonably underground in the Swains. There's much more work out there than we have the capacity to go and do. Right? So what we do is we bring together a whole stack of metrics, and we draw upon both empirical data from AIMS, the Reef Field Management Program, the COTS program itself, to a degree the tourism industry through all the, you know, for their important sites. We wrangle all those ecological metrics together in these dashboards that have been built by Sam Matthews within our team at Rompa. He was a previous PhD student of Morgan's. And this has allowed us really to tweak all these variables and to visualize various outcomes, right? So we then bring in the tourism value, and we base that on the visitation rate for all these reefs. There's some reefs in the park, like Moore Reef offshore Cairns, that has well over 200,000 person day visitations per year. And so it's the most important tourism reef in the whole park. There's others offshore the Whitsundays, to a lesser degree, Townsville and the Capricorn Mocha Group, which are also important reefs. But, you know, so these things get upweighted a little as well. Sam, during his PhD, developed this COTS risk model, and that allows us to actually look at the risk of the exposure risk of various reefs to actual COTS outbreak and their ability to be able to spread the outbreak further down the line. Of course, the current status of coral in those reefs is important, and so we have to wrangle all these things together. And we also use the Rompa's reef resilience model, which essentially puts reefs into 4 quadrants, you know, sort of high disturbance, low recovery, high disturbance, high recovery, low disturbance, low recovery, blah, blah, blah. So we use that sort of thing as well. We then, once we've done all that, we go to workshops and we work with our program partners. Morgan was at a workshop we ran a couple of weeks ago, to actually get that expert sort of elicitation from the field. This is our draft list that we produce. We go to the group, we say, right, this is our proposed target list for the next financial year. What do you reckon? Are these reefs going to be good? What have you got any further intel? Is it anchorages? Is the currents too strong? Is it, you know, all of the logistical filter, the feasibility filter? We all have to bring that into the strategic planning of the program too. On the current list, we have 600 what we call priority reefs, and they're spread between, well, across the entire marine park, and they're vulnerable to COTS outbreaks at various stages of a sort of 15-odd year outbreak cycle. But, you know, those outbreaks are variable in space and time, and at certain, from year to year, we need to retarget our efforts to the right places at the right time, and that's why we have a shorter list of target reefs. And at the moment, we have 213 of those for 21-22. So in this year, we're trying to action just over 200 reefs. And we feel that with the current capacity that we have with the COTS program fleet, we can action about 200 reefs a year. The way it's going over the next couple of years, we're going to have a slightly increased level of capacity, and we feel that in perpetuity, we should be able to keep on top of COTS on about 300 to 500 reefs in the long term. So when we go and we action a reef and we count COTS, we reduce their numbers, we suppress them to sustainable levels, we then have to keep an eye on that reef. We have to keep monitoring it every 6 to 12 months, depending on the status of the reef. And that allows us to make sure that the COTS outbreak isn't reinitiating on that reef, because, you know, we're essentially working in the shallow parts of the reef. COTS will often come up from deeper water up onto the shallow slopes, up onto the reef crests. And so if we clear out the shallows, but they're still munching out down below, and then we leave the reef and then they just move back up and we start losing coral there. So we have to keep a close eye on those reefs. And we also need to ensure that the investment that we've made in those reefs was the right reef to invest in, right? We have to be, you know, sort of transparently assessing what we're doing in the program. It doesn't come cheap. So as I said, there's 600 reefs at the moment across the park, and there's 213 that we're targeting this year. Next year, we're going through this process again for this coming financial year, and it's probably going to be 215 odd target reefs for the next year. So what do? Well, when we get to a reef, so we've identified the target reef, we get to it, and the first thing we do in the integrated pest management framework is that we mandatory the reef. And it's just similar, it matches the AIMS standard operating procedure for the AIMS long-term monitoring program. So they do an entire loop around the perimeter of the reef. In some cases, they'll push up into the lagoons, they'll check some of the bommies and some of these back reef kind of areas and back reef bommies. Anywhere they, you know, most of those, all those green lines, I don't know if you can see it, but yeah, most of those ones that are green lines, they're places where we saw zero COTS. That's actually Davies Reef, offshore Townsville. The yellow places are places where we've seen low numbers of COTS, or their scars, and the red places are where there's high numbers of scars, all right? So wherever we are able to identify the COTS, and they're often very patchy, very, you know, aggregated in certain areas, we then deploy the cull team, and the cull team go and move through that site. So you can see, you know, all those little polygons sort of end to end around the reef. Well, each one of those is cull site, and we set those up at the start of the year when we define the priority reefs. Each one's 10 hectares roughly, and then we're able to assign the effort to specific cull sites. When we do that initial surveillance of a reef, we also do RIS surveys, which is the Reef Health Impact Surveys, which are fairly quick and dirty method, but they give us some additional information on coral community structure. They tell us about some of the other impacts on the reef, like coral disease, and physical damage, bleaching. They also pick up other things like propeller snails and things like that, other COTS predators. So we deploy them, 3 to 6 of them, depending on the size of the reef, within each quadrant of the reef, so northeast, southeast, you know, etc. So we're putting them around to give us a little bit more detail onto what the mandatory. Once we actually start diving, we obviously move methodically with a dive team, usually 8 divers, through each one of those 10 hectare cull sites. And what we're going for is a catch per unit effort target of 0.04 COTS per minute if the coral cover is less than 40% across that entire reef. If it's high coral cover, you can actually sustain more COTS on the reef. So we set quite a slightly higher catch per unit effort target. So this is the level at which we think if we suppress COTS to that point, coral growth can outpace the rate which is being needed, essentially. So that's what we're trying to go for, is a catch per unit effort target. And then on the sites where we're actually doing a lot of intensive culling, like some of these cull sites, you know, the initial CPU might be, you know, 1, 2, 3 per minute, even higher in some cases. And we know we're going to be on those sites for a while, right? We're going to have sites open. So we also deploy these RIS on the cull sites to give us a bit more information on what we're actually achieving at a site scale, rather than the entire sort of reef scale estimate. Now, at the moment, we've got 7 vessels on the water actually doing work. Since 2012, this entire program has been $65 million roughly invested in the program over that time. Obviously, over the next 8 years or so, we've got 160 million going in. So it's nearly a 3-fold increase over a similar, over a slightly shorter amount of time. So it's quite a big additional investment in the program over the next 8 years. So we're essentially going to be running at around about $20 million a year to deliver the program. So it's a big investment. But since 2012, we've actioned over 330 reefs. Most of those have actually been actioned since 2018, when we came to the capacity that we're sort of at now. We've surveyed a lot of area. We've done a lot of RIS surveys. We've put in over 79,000 diver hours, so there's a massive amount of diver hour effort. We've covered 1 million COTS. And this area managed, this greater than 81,000 hectares, this is actually the combined area of all those cull sites around the reef. So if we add all them up, and on all the reefs we target, they sum to about that. If we look at the habitat or the reef outline maps on which the Great Barrier Reef zoning plan is based, the total area of reef habitat, which we know there's areas with with those maps, and they're not that accurate, but we're talking over 700,000 hectares of habitat area protected from COTS predation. So it's a massive. When you start like looking in the dollars that we're actually investing in this versus how much area we're protecting, at this number, which is undoubtedly high, it's costing us about $44 a hectare. At this number, 81,000, so the area managed around those reef perimeters, cull sites, it's costing us about $400 a hectare. And if we look at just the actual cull sites where we're working, so the places we're actually culling and just that, it's costing us about $2,500 per hectare. If you compare that to actually putting the reef back together with actual active restoration, and plus the time it takes to grow little whole numbers or larvae or whatever to establish colonies that actually produce their own babies, you're looking at somewhere in the order of $500,000 Australian dollars per hectare to actually do that. So by keeping, it's much, much cheaper to actually suppress COTS effectively and exclude that source of mortality, coral mortality on those sites, keep the corals that are there, those big mature colonies that can actually produce a lot of eggs. It's much cheaper and much more effective to keep them there in the first place than trying to put them back together with active restoration. Not to say that active restoration doesn't have its place now experimentally, and in the future potentially something we deploy at scale, but it's nowhere near it yet, which is why it's been funded with research funds to try and get it up and going. So since 2018, we've had 5 vessels operating. This year we've rolled out an extra 2 because late last year we detected what we defined as a new primary outbreak, and that was on reefs between Visit Island and Cairns. So for the last year or so, the tourism industry on some reefs has been saying, hey, we're seeing an increase in numbers of juvenile COTS on these reefs. We started to see that we were then seeing an increase in numbers of adults on a few reefs. And it was a pretty clear indication that if we don't get on top of it early, we're probably going to have another primary outbreak emerging while we still have serious COTS outbreaks happening in the central and southern GBR and the far north. So we had to really jump on it. So we deployed an extra couple of vessels this year, and they're on for about 6 months to really try and suppress those COTS populations in the northern region. We're on top of that now. So we work closely with the Reef Joint Field Management Program, which is the marine parks vessels mixed out here. We work with the Ames LTMP closely, plus the people that are working on eDNA for cost detection, a bunch of other stuff. We obviously work with JCU, we work with UQ, University of New South Wales, and increasingly the tourism industry. We had the Master Reef Guides program and other things like that, which are proper initiatives. But we're getting some of those tourism operators trained up to the next level where they can actually produce reliable data in water. So that can, again, provide another valuable source for us, not just in terms of detecting COTS, but also telling us about the coral condition on those particular reefs. So if if we're relying on a coral model that actually predicts what the coral cover will be on a reef because we don't have empirical field data on it, and we have a tourism industry operator that we can rely on to go in there and do a few risk surveys for us and just a better estimate of what the coral status is on any particular reef, we could use that empirical data from the field rather than relying on the models to tell us what the coral status is. So it is useful, and the tourism surveys are slowly getting better. We are effectively suppressing COTS across hundreds of reefs. And you can see this is something we used for our progress report just recently. But if you look at sort of 2021 versus 21, 22, the percentage of the manitoes with scars on them is about the same, declined slightly, but the mean number of COTS per toe is actually almost half. And that's on the reefs that we've worked on across both years. So a lot of these reefs we're on for, it's not like we're just there for one voyage or two. Some we are, we don't find any COTS, but for a lot of the reefs that we're actually on, we detect COTS. We have to establish culling. It takes multiple repeat visits to bring these populations under control, right? It takes time and effort. So we need to make sure we're doing that. So each one of these 5 to 7 vessels is doing about somewhere between 230 and 280 days on water per year. So collectively across the entire fleet, we're up around 1,500 on water days per year with a dive center for 8 on each of those vessels. It's a lot of hours. It's a lot of time. And in terms of coral protection, you can see that across the reefs that we're actioning in both years, this is just the last 2, you can see that coral cover has been relatively stable on those reefs. And these reefs are mostly ones that are actually getting hammered by COTS, right? So If we weren't there and we weren't actually suppressing these COTS, we would definitely be losing coral on these reefs. So coral's been relatively stable. This is based on mandatory data. If we then zoom into the cull sites where we're actually reducing COTS numbers, you can see that across all those sites, this is done last year, and this is some initial modelling that Sam Matthews has done for our team, and we've got more to do on this. We'll be doing it again soon with more collaboration with a whole range of researchers. But across the cull sites, the average CoralCoE last year was about 25%. So we observed about a 4.87 absolute loss in absolute cover of coral cover per year. This is annualised across those previous few years, right? That was the reason we were culling on, specifically at the cull sites. We knew there was COTS there. We were on for a period of time. We observed about nearly 5% loss. Sam's run this model, and had we not culled those COTS, we would have ended up with somewhere up towards 18% loss, absolute cover per year of coral. So, you know, over several years, all the coral's gone. And that's an average across all those reefs. There's some of these reefs in the Swains where the COTS numbers are so high when we get there that all the coral will literally be within a year. You know, coral cover might be up 60, 80% cover, mostly crocodile dominated reefs down there in the Swains. There's that many COTS there, they're like a blanket, and whatever's there on that reef will be eaten within a year. So we then have to make pragmatic decisions. Just because we have a reef on our target list, if we get there and we find densities of COTS like that, we're not going to be able to get on top of it. So we have to then make some really pragmatic and sometimes tough decisions to actually walk away from a reef at that burn, because it's not worth us investing time and effort in that reef if we're not going to catch it. Essentially, we've got to be ahead of the curve. We've got to be ahead of, if you think about like fire management, we've got to be ahead of the fire front. We can't be back in the fire zone where it's already burned over the hill, missed our opportunity, right? We have to be ahead of it, and we have to try and establish lines where we can contain. And in places like the Swains, our regional objective in the Swains is actually just to protect coral on a small number of target reefs, because the problem is too big for the current capacity that we have. In other places like the far northern region, it's a similar story. Is that, you know, although Morgan's found reasonable sort of densities of large COTS in several reefs, we could probably get them out and potentially suppress spawning. I think one of our key objectives up there, given the limited capacity we have, would be to protect coral. In the northern region, between Cairns and Lizard, our main objective in that region is actually to suppress COTS reproduction to the point where we can potentially short circuit some, if not all, preferably all, but it's probably a long shot, to suppress some of the spawning that's going to then exacerbate and perpetuate the outbreaks that move south. So if we can be there early enough, we can find those aggregations of potentially sub-adult COTS, we can start culling them when they're efficient to cull and reduce the adult densities, we may have a chance. But we've got to remember that each one of these adult COTS like that can produce how many eggs? 60 million in a single spawning egg. So, you know, we're talking about massive numbers of larvae added, billions and billions of larvae. And they're going to be dispersed over tens to hundreds of kilometres potentially. So, you know, to do this at scale, to really short circuit an outbreak early enough in the northern region or wherever it may arise, is incredibly difficult to do. And it may never be achievable. But the indication that we have now is that if we can effectively suppress the COTS numbers and get them down, if we're really trying to short circuit spawning, our target CPUE is actually down at 0.01. If you remember, we had when coral cover was about 40% or less, we have a target CPUE of 0.04. If we're trying to actually suppress spawning, we've got to get them down to 0.01. So that means the density of COTS is so low that essentially their ability to find each other and spawn is reduced, right? So at 0.04, we're probably still not short-circuiting enough of the spawn. So regional objectives is something that we really need to do more of, and think about what specific objectives we're trying to achieve in each area, and that will reflect how much effort we invest in each area. So there's a lot of strategy planning. To do all this, we need to work closely with our research partners and with the industry. You know, tourism industry, to a degree, the fishing industry. You know, there's lots of stuff we can do to actually amplify the benefits of this program. We're not all the way there yet now. So this is just something that we've been essentially just starting to keep this idea around. So, you know, when we have a major bleaching event or a storm event or whatever, and we see that, you know, let's say that you have 95% mortality on a reef. but there's always almost always some coral colonies on the reef that will make it through, right? For one reason or another, their genetics, particular zooxanthellae clades, whatever it may be, the position on the reef, means that coral makes it through when all its neighbours, of the same species in many cases have died. So we don't necessarily know what all those mechanisms are, and there's some that we understand. But if we can protect those ones that have made it through, for whatever reason, they're strong corals, right? And if we can, well, they're either lucky or strong. But if we can protect them, and particularly on a reef that we've identified as being very important in terms of marvellous source value, then we can potentially select for or help to select for those strong colonies in the long term. So over decadal scales, potentially, if we're selecting for particularly strong corals and stopping the COTS from eating what's left, stop the COTS from eating those corals that are left, because often, like after a bleaching event, there's COTS on those reefs, corals die, you'll see the COTS actually racing each other, sometimes in a day, to get to the next live colony, right? So whatever's left essentially can get mopped up by COTS. If we lose those colonies out of the gene pool, we're not getting their babies being ones that are going to be replenishing the rest down the line. So, it's these sort of decisions that we're having to make in real time. We're having to adaptively manage the program essentially from voyage to voyage. So we do our planning, I guess, at the moment we're doing planning for 8 to 10 years, but then we do our annual planning. And within the year, we have to be adaptive enough and responsive enough to the intelligence that's coming in. And luckily, we're in a position to be able to do that now. And the program's never been at that level before. So we do now have the capacity. We've got long-term funding security. We've got a degree of knowledge. We have always more knowledge than done. There's a big COTS research program that Morgan's one of the leads on. It's called the COTS Control Innovation Program. It's funded by Reef Trust Partnership for the next few years. There's going to be some good research done under that. All of that research feeds into management. And it's all very, applied, focused research. And it's extremely useful to helping us decide what we're going to do out on the reef. So obviously, as I said before, the zoning plan is central to the reef, absolutely. But the Reef 2050 plan and what we're going to do now to sort of instill additional resilience in the coral reefs throughout the park is, clearly, this mitigation to living climate change is obviously the biggest thing I've said several times now. But effective, local to regional scale management is critical. We've got to try and reduce the various stresses that we can control. There's only so much we can do. And I know that when there was this $1 billion investment announced, people, some people, even within our industry, within the science industry, going, why are you spending, another $1 million on the reef and this and blah, 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 and climate change is the biggest problem in this. Yeah, okay, but don't look at it, we should be congratulating every dollar of investment in the reef. We want to encourage the governments to invest every damn dollar they can in the reef. What we don't want to be investing in is fossil fuel subsidies. I work for the government now, I be careful what I say, but I'd say that for the billions of dollars that are invested in fossil fuel subsidy, look at that. There's a lot of good that's been done with the money that's been invested in the reef. Okay, it's not going to be a silver bullet. It's not going to save the entire reef. It's not, this is the big problem here. It's a global problem, and it's not just the reef. It's everything. It's the stability of ecosystems all around the planet, and human populations around the planet, cities and towns and agriculture systems, and food security, all of it. So we've got big problems, but we can deal with it with small to medium regional scale adaptation strategies, and one of them is the COTS Control Program for GBL. So thanks. Open up to questions.